So I mentioned earlier that we can use systems of equations to solve supply and demand equation problems where we have to find the equilibrium point. So the equilibrium point is a place on the supply and demand curve where the supply meets the demand. So the place where the supply is equal to the demand is the place where we call, is the place that we call equilibrium point. Okay, so we can do that the old school way using algebra, or we can use the systems of equations to solve the problems. So take a look at example 5, pause the video and see if you can understand what is going on here. And let's try to solve the problem and find the equilibrium point in this situation. So again, we can think of the problem as being y equal to 90 plus 30x for the first equation, and the second equation being y equals to 200 minus 25x. And since we want the demand to be equal to the supply, we can now try to solve this problem using that trick, or we can just imagine that this is a graph of two lines and graph the lines on the TI calculator and find the intersection point. Now I'm gonna just use the substitution method here because it just makes a little bit more sense. So the first equation that I wrote represents the supply of x units, and then the second equation that I wrote represents the demand of x units. And since I'm looking for the equilibrium point, that just means solve the system. So I'm gonna go ahead and do elimination and substitution, whatever, it doesn't matter really. I'm gonna use substitution for this problem to do the following. It says in the first equation that y is equal to 90 plus 30x. So I'm just gonna grab that 90 plus 30x in my hand and I'm gonna put it into the second equation. When I do that, I end up with the following. So equation 2 becomes the 90 plus 30x, which is now equal to 200 minus 25x. This is, by the way, equivalent to saying I want my supply to be equal to the demand, right? Remember, the supply equation was 90 plus 30x, and the demand equation was 200 minus 25x. So, I didn't have to write it as a system, even though I can. In any case, I want to try to solve for x. So first, I'm going to move all the x's together to one side, and I'm going to move all the numbers together to the opposite side. And this means that 55x is going to be equal to 110. So that tells me that x is now going to be 110 divided by 55, which is 2. So 2 represents the number of units, and keep in mind that x is in thousandths. So I need 2,000 units. So in other terms, I need 2,000 star satellite radios. Now, if you want to know what the actual supply or demand is going to be, we can plug 2 into one of the equations. It doesn't matter whether you plug it into the first equation or second equation, you're going to end up with the same number. If you plug 2 into the first equation, for instance, you get 90 plus 60, which is 150. If you plug 2 into the second equation, you get 200 minus 25 times 2, which is again 150. So that's supposed to happen. It's supposed to be the same number at the end. And that number represents the dollar amount.